84% of what number is 22? So I can, now that I have found the number, okay, I'm going to look at this first part and see if it's actually true. Okay. 84% of 26.19. Okay. So this is going to be 0.84 times 26.19. And what number should I get? If I was correct, that number is 22. So let's check. Going to put 0.84 times 26.19. That's equal to 21.9996. All right, so that's not exactly 22. Does anybody know why it doesn't come out to exactly 22? You can message me, you can unmute yourself and say it out loud. Either way, does anybody have an idea of why that's not exactly 22? One person messaged. Oh, they were just commenting on something else. Well, I'll tell you why. The reason is because back here, when we did the original calculation, we said 84% of what number is 22. Remember that it had actually several decimal places. And what did we do? We rounded to the nearest 100th, which means as soon as we rounded, we lost all of these other decimal places. They all have numbers. And because we lost that, this number here became slightly less accurate. And so when we plugged it back in, you'll notice that 21.9996 is very close to 22. In fact, all I would have to add to it is 0.0004. If I add 0004, I get right back to 22. So what that tells me is I've introduced an error of 0.0004. And that error is tens, one hundredths, one thousandths, 10 thousandths. So I've introduced an error of 10 thousandths. Now, this is important to realize because up until this point in most of your mathematical journey, most answers are going to come out pretty close to natural numbers or whole numbers. But we're going to start as we move forward in several different, especially in science class. These numbers are not going to be as whole because that's kind of the real world that we live in. You know, when you'd have a board that you're cutting, for example, and you take a measurement, let's say that you cut 10 boards and you cut them all at 8 feet. Okay. If you were to take those 10 boards after you cut them all and line them up right next to each other and go in with a magnifying glass and look at are we exactly 8 feet on every single one, you would notice that there would be a little bit of variation. Probably not enough variation to matter for the construction project that you're doing, but there's a little variation nonetheless. And so it's important that we understand that that's kind of the world that we live in. For example, at the job that I have, we build systems from engineering drawings. And those engineering drawings have tolerances. So if they have a piece of metal like this that's welded to another piece of metal here, we'll say that this distance from here to here and this distance from here to here is a certain value, but then you'll see on the drawing plus or minus 1/16 of an inch. Okay. That means that this, once it's all fabricated and put together, it'll be, let's say, 8 feet, but it might be 8 feet and 1/16. Or it might be 7 feet and 15/16, right? Plus or minus a 16th. And so when we do math, understand that the more decimal places we go out, the more accurate that number is. Okay? So this is one of the reasons why irrational numbers, like the number pi, is so interesting because it does not have 3.141592654, so on and so forth. I forget how many digits it's been calculated out to, but millions of digits. It doesn't repeat itself, but there's no way that we can put two numbers, two integers, in a ratio that gives us this same number. But what we know, because there are circles in the real world, we know that if we know the circumference of the circle and we know the diameter of the circle, that those two are related by multiplying pi. So there are real world distances that are irrational. And this was one of the things that the ancient mathematicians had a real hard time with. They knew that negative numbers, for example, did not exist. They knew that the number zero did not exist. So, for example, zero doesn't exist. If you say, well, I have $5 and then I spent $5, therefore I have $0. What do you mean zero doesn't exist? Well, that $5 did not disappear. It simply changed locations from your possession to someone else's possession. So we can use the number zero to determine that your location with that number is zero, but it doesn't mean that the $5 has been annihilated. Even if you were to take the $5 and burn it, it would decompose into molecules. It doesn't actually go to nothing. Okay, so the ancients were aware that when they introduced the number zero, it didn't actually it wasn't reflecting anything in the real world. It was simply an idea. And the same thing with negative numbers, right? There's no such thing as a negative number. If you look at your temperatures, this is a good way to explain it, right? You have zero, right? And then you can go below zero. But in fact, that's just a relative number. Zero is simply for the Celsius scale, simply the point at which water freezes. And on the Fahrenheit scale, obviously 32 is where water freezes. But you can go below there. But there's another scale called Kelvin that we use in science. And Kelvin, when it goes all the way to zero, that is the point at which no molecule is moving. And that is what we call absolute zero. It exists nowhere on Earth. We can create it, we can get very close to it in a lab, but it doesn't appear naturally on Earth. But absolute zero means all the heat has been removed. And if all the heat has been removed from a system, I can't add anything to this system that is called cold. Okay, because cold, all it is a relative term. It doesn't mean anything, right? You can add heat to the system, but you cannot add cold. You can only add heat and take away heat. When we take away heat, we call that getting colder. So we have words to describe the relationship, but it doesn't correspond to anything real. And so zero and negative, the ancients realized aren't real things, but they're useful mathematically. What became an issue with irrational numbers is the ancients thought that irrational numbers also couldn't exist. But in fact, they do, as I just demonstrated with the circle, Or they could put two units together, um, perpendicular, unit of one, in the cross, in the hypotenuse there that you may have learned if you've learned the Pythagorean theorem, is the square root of 2. That is an irrational number. So you can actually, if you have 1 foot by 1 foot at a right angle, the distance between the top of this and the top of this is exactly the square root of 2 feet. And so what the ancients realized is there exists real tangible objects and distances that we don't have numbers that can express them in integers or in real numbers. There's no two natural numbers that I can put together in a fraction that is going to give me the square root of 2. Doesn't exist. It's an irrational number. And so because of that, um, they considered irrational numbers very unlucky. In fact, there's a legend. I don't know if it's true, but there's a legend that says when Pythagoras, he had basically a community of people in the ancient world that did math. That when they discovered the irrational numbers, that they killed the guy that discovered the irrational numbers because they considered that to be very, very unlucky or very, very bad. So all right, so let's move on. We've got another type of percent here that I want to go over. So, and that is when we find the percent. So let's write this down. What percent of 72 is 35? What percent of 32, I'm sorry, of 72 is 35? All right. So this one's a little different because what we're now solving for is going to be um, the percent rather than the other two numbers. Okay. So what percent that's gonna be our x, okay, of, that's gonna be multiplying, and then we have 72 that's our equal sign, and then 35. So x times 72 is 35. Okay, so how do we solve for x? If I'm multiplying by 72 by x to get 35, then I can divide both sides by 72 in an effort to get that x by itself. So the 72 over the 72 becomes 1. 1 times x is x. And then 35 divided by 72, you can use a calculator to do that. Oops, 35 divided by 72 is 0.4861, and the 1 is repeating. Notice that I put a little straight line over the number 1. In math, that means that that particular number is repeating. All right, so I have 0.4861, and the 1 is repeating. How do I put that into a percent? I know what x is, but how do I put that in a percent? So remember that percent, right, means per 100. So it's some number per 100, right? Some number per 100 is 0.4861 repeating. Let me write that over here so it's a little bit more clear. Okay, so here, now I have x divided by 100 is equal to 0.4861. Okay, now since I have x here and now I'm using x differently, it's more proper if we change the letter here. So let's change that to y so we don't confuse our x and y. Okay, So y divided by 100 is 0.4861 repeating. Now, if I'm dividing by 100, the way that I get y by itself is I multiply by 100. So 100 times y divided by 100, the hundreds cancel into 1 times y is just y. Now, 100 times 0.4861, you don't have to use your calculator here because it's easy when you're dealing with tens. This is 100, so I'm literally moving this decimal place over twice. 48.61 repeating, that's y. Okay, so my percent is 48.61 repeating per 100. Okay, so we could write this then, if we wrote it in percent form, we could say 48.61 repeating percent. Okay, we could write it that way. Now, normally we would have some type of rounding. So if we assume that they wanted us to round to the nearest whole, okay, round to the nearest whole, then that would be here. We'd look at the 0.6. That 6 means this next number to its left has to go up. So if we rounded to the whole, that would be 49%. And that makes sense because 49% is about half, and 35 is if 35 is half of 70, and so 35, if I have a slightly bigger number, then that would be slightly less than half, and that makes sense at 49. All right, any questions there? I know I kind of went on a tangent about zeros and negatives. Okay, so let me make sure that I've got everything covered from what's going to be on your homework. Give me just a second. I'll pull that up. Into the class here. Let's look at the homework. Whoops. Okay. Okay, let's see. If I've done all the forms, what percent? What is a percent of another number? Okay. All right, so let's do this. Let's do one like this. 18% of what is 90? Let's do one that's like that. Okay. 18% of what is 90? So if you think you've got a good handle on this and you want to work ahead of me, that's fine. I'm going to work this out step by step, kind of in how I've taught you. And go ahead and message me the answer if you think you know what it is. But I'll go ahead and write this out. Okay, so this is going to be 18 over 100, 18 per 100 per century, percent of is going to be multiply. What? That's going to be my variable. I'm just going to choose x is going to be my equal sign 90. So 18 over 100 times x is equal to 90. 18 over 100 is 0.18 times x is 90. In order to get x by itself, I'm going to divide both sides of this equation by 0.18. And 90 divided by 0.18 is 500. Let me show you that. 90 divided by 0.18. 90 divided by 0.18 is 500. All right, so let's see if that makes sense. Is 18% of 500 90? So 18% of 500 is, so that's 0.18 of 500. Let's see, 0.18 of 500 is 90. Good. So we were able to do that effectively. All right. So now let's apply this to some ideas just beyond the raw numbers themselves. Okay. So let's say that someone gave you $18. Okay. And I'm going to ask the question, $18 is what percent of $637? Okay. $18 is what percent of $637? So this might be useful in a situation where, let's say that you have a business, you make 637, or let's say that you make $637 and then you pay out all of your costs and you're finally left with $18. And you want to know, okay, what is my percent profit here? Because it cost, if I made 637 and it cost me everything but $18, right? So if I say, okay, 637 is how much I made, and then I had to um so 619. So if I made $637 and it cost me $619 to do that, then at the end of the day I'm left with 18. So I haven't lost any money and I didn't break even. I'm actually right at 18. But I want to know what the percent profit that is. Okay, so that's what we're going to do here. What percent of 637 or $18 is what percent of $637? So 18 is what percent, it's going to be X, of 637. Okay, so 18 is equal to X times 637. In order to get X by itself, I'll divide both sides of this equation by 637. And here, I will take 18 divided by 637. And that gives me 0.02827. Okay, that's enough decimal places to get to where I need. All right, and this is my percent. So that means that my y over 100 is equal to that number, 0.028257. Now, the easy way to do this is we can just, now that I know that I'm going to percent, I can just move two decimal places to the right and get 2.8257%, right? So here it just shows you where that comes from. I'm multiplying both sides by 100. I'm left with y is equal to 100 times 0.028257. That is 2.8257. And so here we see about 3%. Okay, so 2.85 or 8257. So if I rounded to my hundredths, I would say this is 2.82%. If I rounded to tens, so this is to hundredths. If I rounded to my tenth, this would be 2.8%. And if I rounded to a whole, this would be 3%. So if I just rounded to a whole for an easy number, 3%, then I know that my profit is 3%. So then what I can do with that is I could say, okay, Well, then instead of making 637, let's say that I make 10,000, right? What's my profit going to be? If my profit is 3%, 10,000 times 3%, and then I can see how much money I'm going to make from that. So $10,000, whoops, times 3% is 0.03. That's 300 bucks, right? So this is how algebra begins to help you when you guys have businesses, when you're out there in the world kind of um, doing your things. When I'm figuring out finances and stuff, I'm using algebra all the time. All right. Any questions so far? Okay.